Welcome to the class. In this class we are going to learn transport layer. Transport layer is responsible for end-to-end connectivity. End-to-end connectivity means that it is going to use sequence numbers and acknowledgements for proper delivery of data. It is also known as the heart of the OSI layers. So these are the following tasks performed at transport layer: identifying transport service session multiplexing, segmentation, sequencing and reassembling, error correction, and flow control. So we are going to discuss one by one all. Identifying transport service is that transport layer basically has two transport mechanisms or two delivery methods. So these two are TCP and UDP. So TCP stands for Transmission Control Protocol and it stands for User Datagram Protocol. TCP is connection oriented service. Connection oriented service means that before any transmission takes place between two hosts, a connection needs to be established. And that connection is established using three-way handshake process. What does this three-way handshake do? Here, the requester, the source, sends a SYN segment. The SYN segment is basically a request to establish the connection. The receiver or the server replies back with SYN plus ACK. So this SYN plus ACK means that I have received your SYN request and this is my acknowledgement to your SYN request. When source receives this segment, it knows that server is also ready to establish the connection. Then it sends back an acknowledgement saying that I have received your reply to my request, and that finally connection state is to be called as established. So this, due to this method in TCP is called as connection oriented, but UDP is connection less. What does it mean? That for any transmission to take place in UDP, there is no need of any connection. It directly starts sending data, whatever the data it needs to send. So the next is TCP uses acknowledgements. So this is the main point in TCP, because if you lose on some data in the transmission, then if you are using TCP delivery method, then TCP is going to guarantee for the lost data. TCP is going to make sure that the lost segments are to be resent, and this retransmission is called data correction. But in case of UDP, because it does not use any acknowledgements, that's why we say that there is no acknowledgement in UDP and it is unreliable. And due to the acknowledgements and delivery mechanism, it is reliable. But due to using sequence numbers and acknowledgements, it is slower, of course. It includes or it has some overhead involved in the transmission, but it is faster. So unreliable does not mean that it's not good or it is good. It depends upon the kind of application and upon the use you are going to make. So on the basis of the applications, on the nature of the applications, you are going to use a particular transport. So if you want HTTP, FTP or SMTP kind of traffic, then you go with TCP as the transport. But if you are going to use the applications like DNS, DHCP and TFTP, where you just require few messages exchange, then you go with UDP. And you also go with UDP when you require faster transmission, like real-time streaming, real-time video streaming, where you require faster throughput, you go with UDP. So the protocol number with TCP is protocol number 6. Now this protocol number is, if you go to the internet and you search protocol number list there, then it will open up this table, and in this table you can see protocol number for TCP, it is 6. So we need to make a difference between protocol number and the port number. So port number are the exit and entry points for the services or the applications running on some kind of transport like TCP or UDP. So here in this application we are discussing the protocol number. So TCP has a protocol number of 6, and there are few ports or the services running on this TCP mechanism, and there are few other services running on UDP protocol. So this is three-way handshake which we already discussed. So the one of the functions of the transport layer was session multiplexing. So session multiplexing means that it is the ability to have multiple concurrent sessions open to one or many hosts. So if you see here, let's say this is your server and you want to make a telnet session with the server. So you send a request, and this request has a source port dynamically generated as 50,000, and destination port for sure for telnet is going to be 23. But from the same computer you are opening up a new session which is session 2, and it is going to assign automatically a different port than the previous one. It is to differentiate or multiplex among multiple connections, but destination port is going to be same, 23 and 23. So by using these port numbers, server is also able to differentiate between these two connections. But if you think that a new request arises from a different computer having same source port as of one of the sessions from this computer, and it is possible it can be two same ports from two different computers, but it cannot be same on the same computer. The source port cannot be same on one computer, but it can be same from a different computer. So this, now a big question for this server is how to make a differentiation between this connection which is having the source port of 50,000 and this connection also having the source port as the 50,000. So now comes the role of IP address. So it is coming from a different IP address, and this is from a different IP address. So you can say that transport layer multiplexes the different connections using the IP address plus port numbers, and this is something called as socket. So socket is used to multiplex many or multiple connections, multiple sessions open to one server or many servers. So one of the functions of the transport layer was segmentation. Segmentation is you have got this data, a bunch of data, and this data needs to be segmented or partitioned into small pieces for proper delivery of the data. So like you have got this data from the application layer, so this needs to be segmented like this: hello, how are you, for proper transportation, that it is transported to the destination. So sequencing and reassembling function of the transport layer is that you have got this data, this is segmented, and it is also given a sequence number. Then on the destination side, this is going to be reassembled. So the destination B may have received the segments not in correct order, but transport layer is going to reassemble it in the correct order. So it received the segments first 4 by 5, 1 by 5, you, hello, how, are. So that doesn't make any sense, but after reassembling this by the transport layer, it makes sense. Hello, how are you? And this data is given to the upper layer, that is application layer of the TCP/IP model. So error correction function of the transport layer is that, let's say you have these 5 segments to be sent to the destination, but when you are sending, one segment is lost. At the receiving side, the destination B comes to know that one segment is missing. Then it may request to the source transport layer saying that I did not receive that particular segment. Then computer A is going to send back the lost segment, and this retransmission is called as error correction. So by using the acknowledgement numbers, it is going to request that I did not receive a particular segment due to loss in the transmission, please resend it. And this is how sender A is going to retransmit the data. So this 2 by 5 which was lost is retransmitted now, and this is how the actual data is received by the destination. So the last function of the transport layer is very important, that is windowing, and this windowing is used to flow control. Flow control is that it is a mechanism to make sure that sender is not sending more data than the receiver can process or receiver can handle. So it is the mechanism to make sure that. So how it is done? By using the concept of windowing. So windowing is that sender and receiver both negotiate before any transmission takes place that how much data they can process. So for example, sender sends 3 window size. 3 window means in one window 3 segments are there. Then these 3 segments are sent out to the destination and all 3 are received. That means a receiver easily can receive 3 segments. Now it is sending 5 window, means 5 segments at a time. So 5 are sent to the destination but 4 are received. That means a receiver capacity is to just receive or process 4 segments at a time. That means both have negotiated that we can send and receive 4 segments in one window. So this is how they control the flow of the traffic. So they conclude, both of the computers can conclude that PC A can send 4 segments at a time to PC B. So if we talk about the data flow, so data will be data, PDU will be data from the application, presentation and session, and in TCP/IP it is just all 3 layers are just application layer. So we can say that PDU is data at application layer, and at transport layer data is encapsulated with transport header containing the sequence number, acknowledgement numbers and port numbers, and then this, after encapsulation, it becomes segment. It is called as segment. So in this video we learned about the tasks or the functions performed at transport layer. So those functions are identifying transport service, connection or session multiplexing, segmentation, sequencing and reassembling, data correction and flow control by using windowing. I hope this video has been informative for you, and thank you for watching.